everyone, welcome to my channel Chemistry is Fun. Today we will deal with the topic measurement of the conductivity of ionic solutions. Now see, if there is a metallic wire, then the measurement of resistance of a metallic wire can be measured with a Wheatstone bridge. But in measuring the resistance of an electrolytic solution, we have certain problems like if we pass direct current through the solution, then it will change the composition of the solution due to electrolysis. And also a solution cannot be connected to the measuring bridge as we do in case of a metallic wire or any other solid conductor. Now these difficulties can be resolved by using an alternating current as a source of power in the place of DC source, and another problem can be solved by using a specially designed vessel which we call as the conductivity cell. We can get it in several designs. The diagrams are given. So there is a specially designed vessel called the conductivity cell. Now see, here we can see a conductivity cell in which there are platinized platinum electrodes and there is a conducting wire connecting the two. So in the cell there will be two platinum electrodes which are coated with platinum black, and the electrodes have area of cross section A and are separated by a distance L. So when the area of cross section is A and the separation is L, the resistance is given by R is equal to rho L by A, where this L by A is called as the cell constant. Now this cell constant is determined by measuring the resistance of the cell which has the solution whose conductivity is known. So in order to determine the cell constant, we measure the resistance of the cell containing a solution whose conductivity is already known. We generally use KCl solution and we know the conductivity accurately at various concentrations. Cell constant is G and that is equal to G is equal to L by A. Once the cell constant is determined, we can use it for measuring resistance or conductivity of any other solution. Now for any other solution, we need to have a setup for the measurement of the resistance which is given here. We have four resistances R1, R2, R3 and R4. R1, R2, then bottom we can see R3 and R4. There is a detector. So here there are two resistances R3 and R4. Variable resistance is R1. R1 is the variable resistance. The conductivity cell having the solution of the unknown resistance is R2. Conductivity cell having the solution of unknown resistance R2. There is an oscillator O. What is the oscillator O? It is a source of AC power in the audio frequency range of 550 to 5000 cycles per second. It's a source of AC power in the audio frequency range of 550 to 5000 cycles per second and is connected to the, it is also connected to the bridge. P. What is P? P is the detector of null point and the bridge. We say that the bridge is balanced when no current passes through the detector. P is a detector of null point and the bridge is balanced when no current passes through the detector. During this time, unknown resistance R2 is given by R1 into R4 by R3. R1 into R4 by R3. And the conductivity of the solution will be given by cell constant by R. Conductivity of the solution, cell constant by R. The conductivity of solutions of different electrolytes in the same solvent and at a given temperature will differ due to the charge and size of ions into which they dissociate. The conductivity of solutions of different electrolytes in the same solvent and at a given temperature differs. Why it will differ? Due to the charge and size of ions into which they dissociate. And also the concentration of ions or the ease with which the ions will move under a potential gradient. So we have to determine a new physical quantity which is molar conductivity denoted by lambda. Molar conductivity denoted by lambda. It is related to the conductivity of the solution by lambda is equal to kappa by C. C is in mole per meter cube. C will be in mole per meter cube. So I hope students you all could understand the topic which we discussed today. Thanks for watching the video. Please share the video and subscribe to the channel. Thanks for watching. Thank you.